Hi, welcome to the notes for Algebra 2, Section 13.1 on right triangle trig. We're going to start by just looking at a right triangle. This is a review of things that you did in geometry. If we have a right triangle, we have a 90-degree angle, and we have two other angles in the triangle. We're going to call this one theta. That's the Greek letter theta. If I'm thinking about theta, this would be the side opposite, and this would be the side that's adjacent. The hypotenuse is always the side that's opposite the right angle. It's also always the longest side in your right triangle. The six trig functions that we're going to talk about are actually six trig ratios, are the sine, cosine, and tangent, and then the reciprocals of these functions, the cosecant, the secant, and the cotangent. We can abbreviate this instead of writing out each function each time. Like this. If we let theta be an angle, an acute angle in a right triangle, the six trigonometric functions of theta are defined as follows. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. And then we have the reciprocals. The reciprocal of sine is cosecant. Cosecant of theta is hypotenuse over the opposite side. The secant, which is the reciprocal of cosine, is hypotenuse over adjacent. And the cotangent, which is the reciprocal of tangent function, is adjacent over the opposite. So besides those six functions, you also want to keep in mind the reciprocal functions. Now let's try an example. We're going to evaluate the six trig functions of the angle theta. And this is my right angle. This is going to be theta. And this side is 8. This side is 6. And this side I don't know yet. So this would be the given information. What I need to first figure out is the hypotenuse. So I want to find the hypotenuse. And we're going to do that simply by doing the Pythagorean theorem. C squared is equal to A squared plus B squared. So if I label this triangle ABC, then this side would be C, and I can use this formula. C squared is equal to A squared is 6 squared. Small a is always opposite angle A, so this would be A. This would be B, and then opposite angle C would be little c. So 6 squared plus 8 squared. So C squared is equal to 36 plus 64. C squared would be 100, which means C would have to be 10. Now it's only a positive 10 and not the negative 10 because we're talking about an actual length, and a length would always have to be positive. Now when I find the six trig functions, I'm going to use those ratios that we just talked about. The sine of theta, this is theta, is opposite over hypotenuse, so it would be 6 over 10. And then you want to reduce that to 3 over 5. The cosine of theta is adjacent, so that would be this side 8. It makes up part of the angle, so 8 over the hypotenuse 10. And once again, I want to reduce this. The tangent of theta is going to be the opposite side over the adjacent side, so 6 over 8. And when I reduce that, I get 3 over 4. Notice each time that I write the abbreviation for sine, cosine, and tangent, and also the other 3 trig functions, I always have to say sine of what? And it's of an angle, and my angle is theta in all 3 of these cases. Now, my reciprocal functions are cosecant, the reciprocal of sine would be 10 over 6, which is also 5 over 3. The secant of theta is the reciprocal of cosine, so that would be 5 over 4. And the cotangent of theta is the reciprocal of the tangent, so it's 4 over 3.